Okay, there you go.
All right, we're going to get started. Well, thanks for joining, John. Um, and so this is the start of week 6. I think from this week on is pretty much where it's well more into the security aspect of things. For this week, well, for today, we're gonna go through one slide deck that's just more fundamental terminology, and I think that should be the last of just overviews and terminology. Some of this is a bit refresher, and then we'll complete up the network traffic analysis, and then from there we have our first labs with the TCP dump, Wireshark, and some traffic analysis. Um, Day 2, network attacks and defenses. Some more interesting labs. There's going to be a lab where we start doing some credential harvesting. So this one should be kind of interesting as it relates more to red team or attacker tactics, and then some secure network technologies. And so this week should be a bit more relatable or interesting to kind of day-to-day cybersecurity roles. Right. So yeah, so we'll go through this slide deck. There's a lot of terminology that's just kind of and review. So don't get too caught up with the trying to learn a different technology in one slide. It's just the overview for reference later. Network systems and architecture. We've kind of covered a lot of aspects of it. Routers, switches, devices. Today we'll be talking a bit more about some network authentication, some networking protocols that are just for just good awareness as one last overview until we start really getting into network traffic analysis. Some of this is going to be recap. So we've already covered some of the terms and technologies, but we'll get one last recap in for today. Um, so we didn't. I don't think we've talked too much about redundancy methods, but we'll be covering a few right here. So um, whenever you have a complex network, you want to have redundant links. You might have two different cables that connect two different routers or switches. Power goes down between one of those links, and the idea being that your network doesn't just completely get knocked out by one circuit breaker getting tripped, or somebody accidentally yanking a cable or something of that nature. So you want to have redundant links within your physical network infrastructure. Um, However, without certain technologies and protocols right here, highlighting spanning tree protocol, if you simply connect two switches together and they don't have this protocol or a similar protocol in place, you can end up having loops where traffic just continually kind of loops back and forth between two switches trying to go to the right path and never actually get into the destination. So this protocol, I know it's at least for Cisco devices, this applies, and as well as other commercial networking switches. But basically, if you have multiple connections to between different devices, um, it uses terminal. It'll essentially block a port unless the other port goes down. So it'll function on one port, and then it detects that one of the routes goes down, and it'll unblock the other port to create that redundancy. The term people usually say for this is it's convergence. So just for to be familiar with the spanning tree protocol. Um, other other things you can do. Sometimes people with the they have two links like this. Sometimes they'll do what's called bridging the interface, and it'll operate at like the double capacity, so it's using both to go through. And then sometimes it'll load balance. It'll just send traffic alternating through each interface. So a lot of different configurations you can do. This one right here is typically the default when you connect two Cisco switches together with multiple interfaces and ports. Um, just like so, and something to note out, this is mainly spanning tree protocol. It's a layer 2 technology, so it's typically done between switches. Right here we have a hot standby router protocol. So switches are just trying to connect that the physical connection between different parts of the network, whereas routers are going to actually handle that traffic traversing multiple networks. So just like you can have redundant switches that will provide that physical connection backup. Um, this also exists for having standby routers. One router goes down, it'll start directing that routing to another router on the network to have that backup redundancy for routing. So um, I want to say this hot standby router protocol definitely supported on Cisco devices and mostly all commercial devices out there, as well as the VRRP, virtual router redundancy. Yeah, we just talked about network load balancing. So network load balancing is, where you have two connections, and these connections are going to essentially alternate traffic between these two routes to maximize capacity between two redundant devices. Important thing that calls out here: redundant power supplies, sources. Networking. I think most of the times I see networks fail due to power issues. You typically want to have backup power supplies. Either uninterrupted power supplies where it automatically switches to a backup battery, and then if you've got that support, you should have um, backup generators if it's supporting a critical part of the network infrastructure. Um, Something else that people typically have for their production networks, they leverage multiple internet service providers. You'll see some places where they have a primary internet service provider connecting their network, and then maybe they have Comcast for one connection, and maybe they'll have a backup using maybe a cellular type of connection. So again, it's more redundancy methods just to be aware of. Uh, so whenever we're doing secure network design, um, and for that matter, just mostly any design, you want to conduct a threat assessment. Um, there's a lot of different formats out there for that factor in. It could be political environment or geopolitical factors. You know, what is for example, if you're in the government space, you're always going to be looking at what's the nation state threat actor we're concerned about, and then figuring out what those tactics that they leverage. I think in week one we went over the MITRE attack framework. You put in you pick a threat like APT-29, Cozy Bear, Russia, and it goes over what's their techniques, and you want to kind of leverage these models when you're building a threat assessment on what your industry is. So, I used that for the government space. And then if you're in the telco space, there's
Yeah.
certain threat actors that target telco as well. Um, and you also want to take into account policies and guidelines. So, for example, policies would be secure network design around for PCI. There's going to be specific policies that you have to follow if you're processing payment card information. And then guidelines are things like National Institute for Standards and Technologies, or NIST. There's going to be a lot of hardening guidelines for secure network design. And here's some, components that, for example, network segmentation. You want to segment out different parts of your network. You don't want to have, the your core business servers on the same network as day-to-day users that are connecting to the Wi-Fi, especially if it's a guest or public Wi-Fi that you have. Um, Separating development from production, separating out labs from your day-to-day business users. That network segmentation is really helpful for things that might be of different security or trust levels. So you might trust your your employees versus maybe if you have a guest access area. So you want to treat those networks a little bit differently. So you segment them out. Perimeter security. So mm, we talked a bit about firewalls. And the typical old design is everything inside of a building is going to be considered secure within the firewall, and everything on the internet is going to be separated from a firewall. And it's going to just like when we did in these labs, we might let in certain ports and protocols through the firewall. And VPNs, virtual private networks, a lot of places now that we have all so much people working from home, so people leverage corporate VPNs. So you can have essentially people can be anywhere in the world and virtually get into the corporate network. Access control. Um, I think we covered this pretty thoroughly in just about all the sections we went over. You just have that methodology for people to authenticate who they are when they connect to any network. And we want to always leverage encryption. There's tons of protocols out there that aren't encrypted by design. So when you build that secure network design, you want to factor in encrypting those connections between your hosts and services. Network monitoring, intrusion detection. So we will definitely cover this. We'll cover at least security information and event management or SIM solutions a little bit later on. But typically, in your secure network design, you want to be monitoring the events. If you have a firewall router, you want these things to be logged somewhere. And then, the intrusion detection has a lot of signatures that are built into alert. Like it'll have a built-in signature knowing what a denial of service attack looks like. There's a lot of signatures for specified network traffic that looks like an attack. And I think in the next presentation for network traffic analysis, we'll kind of have a few examples of what network traffic it might be looking for. And you want to have those alerts go to your SIM solution where your security analysts are monitoring, and then they'll be able to respond to alerts that they would see. Incident response planning. So the previous slide we're talking about monitoring alerts that come in, and you want to have a plan for what you want to do when those alerts come in. If it's say you're seeing high traffic from a certain IP, maybe your plan is going to say, well, we're just going to block anything from this IP space, or perhaps if you see network traffic for logins from a country that you wouldn't normally have employees logging in from, that would be a response where that's some evidence that maybe that person's credentials have been compromised, and now we have threat actors logging in from for example, if all your employees are in US and they don't have a reason to log in from IPs like Russia or China. Those are the types of alerts you want to build using your IDS, intrusion detection system, sending logs to your SIM, and then having a plan on how to respond to it. So in that case, you'd want to reset that employee's password. Security training and awareness. You'd like to think that all your attacks are going to be detected and by some kind of automated system, but a lot of times your best detectors are going to be the humans in your organization. People should understand what things they should raise alarms for, what things they should be watchful for. So that security awareness training should cover what they should avoid doing, how to secure their passwords, and then importantly, where do they report it? How do they report anything suspicious that they might see on a network? We'll cover some network security systems and technologies in the next few slides. So we already talked about firewalls, but key thing to call out, there's intrusion detection and intrusion prevention systems. So most of these systems can do both, just depending on how they're configured. And there's pros and cons to one or the other. One call out is if you have your intrusion detection system in prevent mode, it could automatically end up blocking legitimate traffic. One of the prevention mechanisms might say if we see a X amount of spike in traffic, automatically block something because it thinks it's getting hit by a denial of service attack. That might not always be the case. Perhaps your company just started a new marketing campaign. Maybe they got a commercial on TV, and then it starts detecting a spike in traffic, thinks it's getting attacked, and then it's really causing a business interruption. So a lot of times, my guidance to folks is make sure if you have anything that's going to automatically block or prevent something, that you want to have high fidelity for those intrusion alerts. You want to make sure that it's not accidentally blocking legitimate uses. So um, any of these automated detection systems, the key is tuning it. If you just turn it on with all the default settings, it'll be noisy. It might block out legitimate uses. So yeah, all these tools, they're not necessarily meant to have work perfectly out of the box. It's always going to take a little custom configuration because every business, every network's a little bit different. So that's a big consideration in your secure network design. We talked about VPNs, but network access control. So this is broad terminology for uh, enforcing access control on network devices. So we talked about MAC addresses in I want to say the first or second week. So a simple network access control could be that any device that's plugged into the network or joins the Wi-Fi, their MAC address has to be on the allow list. Otherwise, they're going to be blocked access for the network. So it's essentially authenticating devices that are on the network. And this is particularly, useful for things that humans aren't necessarily going to be logging into. Perhaps you have a network printer in your building. That'll be something where there's not going to be a human logging into it. So you want to have some sort of network access control. So because it's going to be on the network, and depending on how strict the network is, they might have where it has to be enforced for every device on the network. When I was in the government space, somebody actually had to. It was part of the onboarding process. Somebody would have to record the MAC address of every device, make sure it was on the allow list. Otherwise, you plug in your computer into the network and it would just get blocked. So it can be onerous to manage this, but it is available. We talked a bunch about antivirus, DLP. You should definitely have these things in your secure network design. Secure email gateways. I don't think we've talked about this just yet. So there's a lot of third-party programs out there that you know it'll read or it'll scan emails for malicious links, scan emails for uh, malware and attachments before delivering them to the user. So this will sit somewhere on your network, and it should be en route to your email server. Most email today, this is all happening in the background, like Gmail, Microsoft 365. If you were to just take like a piece of malware, send it as an attachment, and email it to somebody, and if it's, that somebody is using Gmail, Yahoo Mail, almost just about all the main providers, that malware is just going to get zapped, and it will never make it to the addressee because these email gateways are built into most modern solutions. Web application firewalls. So, earlier we're talking about firewalls. It's talking about um, filtering on protocols, ports. Like in that Linux lab with the uncomplicated firewall, it's filtering. We're setting it to allow port 22, SSH, or pings of that nature. Web application firewall is specific to HTTP traffic. So a lot of it'll be able to detect if somebody's trying to do an SQL injection to a form, or it'll detect if somebody's manipulating address headers to try and hack into a website. So this is at the application layer of the OSI model, and it's filtering specifically to prevent web attacks, whereas your typical firewall is operating at layer 3, layer 4 of their OSI model. Security information event management. There's, I think we mentioned Splunk, a lot of other solutions out there. Later on in the course, I want to say somewhere around week 9 or 10, we'll probably do a bit more of a deep dive on some SIM tools. I want to say there's a lab where I think it's leveraging Splunk network monitoring tools. There's a lot of them out there that are going to sit at your network layers, monitor traffic, and look for it'll decipher the traffic and look for signatures of attacks within the network traffic. Secure management and remote access. We'll talk about a few of these technologies and protocols here. Secure administrative access. Yeah, I think we talked on this a bunch. Any of your administrative accounts, you want to make sure you have a MFA. You want to make sure you're possibly using privilege access management, and you want to have some monitoring on these high-level administrative accounts. Role-based access control. I think we talked a bunch of that. It's easier to manage access to resources on the network by having roles and assigning people to roles rather than assigning every single piece of configuration one by one for each user. So leveraging role-based access control is definitely something that you should consider when designing your networks. We talked a bunch secure protocols. If you're using anything out there that's not encrypting the traffic, sending data, credentials, in clear text, it's a significant security risk. I think we covered two-factor pretty well. Secure management VLAN. So this is something that's practiced that I've seen pretty much all over the place. Your network devices typically have management interfaces. So for example, your home router, it'll have like an IP that you can navigate to and do administrative tasks to it. So that's the simple version of it. But in corporate networks, or you have these Cisco devices with management interfaces. You have servers with management interfaces. So what a lot of people do to design their network is they have what's called maybe a management VLAN or management network where you're not going to have regular users on that same network. You're not going to have guest users, essentially segmenting out your management VLAN to where only administrators have access to that network. And then you're kind of reducing the attack surface for people being able to even attempt to log into or authenticate to the management interfaces of your devices. Logging, I would say, my rule of thumb for the cybersecurity side of things is if you've got the storage for it, you can afford to keep, I try to log as much as possible. So if there's a device has a management device, the network device that's people can be logging into, you want to make sure you're sending those logs to your SIM or your security event manager. We talked a bunch about patch management. Things are constantly, new vulnerabilities are constantly popping up. You want to make sure you have a system to regularly patch and also respond to any critical patches or updates for your network devices. Secure out-of-band messaging. So this is something that you should definitely have for key personnel in an environment. In the event that your network does get compromised, the hackers get in, and the worst case scenario is they're going to be able to access the emails. They're going to be able to read your messaging. So when you do have an incident, you want to be able to leverage out-of-band messaging. So for example, day to day, everyone maybe they're operating on Teams or Slack and email. You would have a backup plan to leverage something that doesn't use the same credentials that you're using for those for Slack for Teams. So maybe everyone has a plan to go download Signal for their Android or iOS, and they have a methodology to kind of switch to the out-of-band messaging. So you just want to have a plan in place for out-of-band communication should there be a significant incident. Physical security. this is one that I think it's a big branch in cybersecurity to physical security, but whereas you're not necessarily going to be responsible for physical security, like actually doing it, but you should factor into a physical security plan to any of your servers, your network devices. You don't want to have your switch sitting in a relatively insecure place. Somebody could walk up to it, plug into the management interface, and do some significant damage, similar to servers as well. So you want to at least have a physical security plan on where your assets are going to live, and how are you going to get access to it? Is it recorded? Do we need to sign in a log? All those things. I mean, and of course, we typically have people that branch into physical security as a realm of its own. And we talked a bunch about authentication and authorization. So you're authenticating, you're proving who you are. Authorization is what do you have access to, and accounting is essentially the logging or being able to audit your authentication and authorization. So we have some frameworks here that live in some network devices. So Cisco supports TACACS and Radius. It's essentially, these are servers that you would have your network access users configured in, or you can these things can point to Active Directory for authentication. And we've talked a bunch about authorization and all this here. 802.1x. So we talked about network access control. This is actually a specific protocol that you can leverage for network access control. It kind of does the checking of does this device have is its MAC address authorized to be on the network, and it runs through this process um, to validate devices that are plugged into the network. Definitely, like I said, we're not going to be an 802.1x expert off of this one slide, but it's just to be aware that this is a protocol that exists out there. All right. Like I said, I just wanted to get over this network security fundamentals slide deck. Just a brief overview of some new network security concepts, and yeah, we'll jump right into network traffic analysis. Like I said, this week is going to be a bit more intensive in actually looking at attacks in network traffic and kind of understanding what they look like. So we'll get real started in this, and yeah, this is probably the bit more fun part. So network traffic analysis. So we're actually monitoring network traffic. We're looking at the data packets that are all over our network, and there's tons of tools out there that can take that network traffic, capture it, and allow you to do analysis on it. Take a look at what, and the main purpose in cybersecurity to be able to detect a possible attack. It's important to note though that your network engineers, network administrators, they'll be, they have similar tools that they use for performance monitoring, troubleshooting, and sometimes both teams are using these same tools so that they serve multi-purposes. It's not just for detecting attacks, but that's what we'll be focusing on for the remainder of this week. Data packets. So we kind of went over the model, the OSI model, in I want to say week 2. Yeah, so packets is essentially coordinates with layer 3 network traffic of the OSI protocol. We've kind of touched on all the different traffic types in possible networks, but these ones are typically most interesting from a network traffic analysis. So and a good chunk of it is some network traffic is just noisy, some network traffic is encrypted, some network traffic is doesn't really have interesting information. So we'll be kind of highlighting the ones that would typically have interesting information that you would want to do analysis. So web traffic, HTTP, a lot of times investigating incidents. If you're hosting a web server, you're going to see HTTP traffic coming to your web server all the time. And this is, internet facing, especially if it's some sort of retail or business website. It's important to understand what the attacks look like from a server perspective. So, monitoring what this traffic looks like is really important for any servers that you have on the network. Another use case for HTTP, a lot of times, we have users, maybe they have a malware alert on their workstation. You always want to figure out, how did the malware get to the workstation? Was it a phishing email, or did it come through email? And typically what you'll see is maybe they were sent an email and it had a link to it, and that's where the malware originates. So a lot of times we're looking at web HTTP traffic to see where somebody downloaded a piece of malware from. FTP, a lot less popular these days. Most people aren't running these servers because of how insecure they are. But definitely FTP, you might see, what files may have been stolen from a network. Being able to look at that from a network traffic standpoint is fairly important. Domain name, DNS service. A lot of times, I look at DNS traffic as a good way to start narrowing down my investigation. Certain domains are much more malicious than others, and there's some low hanging fruit, like maybe I'm looking at anybody is reaching out to .cn for China domains, or .ru for Russia, or maybe there's software repository websites that isn't normal for maybe my call center employee to be accessing. If I see traffic from the call center going to GitHub, I mean, that's going to be kind of weird. So a lot of times I'm looking for DNS traffic and network traffic to be able to see if there's anything weird going on in the network. SMTP, again, this is a lot less popular these days. Back, take it 10 years ago, before M365, Gmail, all these other cloud-based email solutions existed. People would be running mail servers all over their network. These do still exist, of course. Some, there's possibly, like I said, devices on a network that may use SMTP servers on your network to send things like the network printer, or the Xerox machine on your network might be using that to send alerts or things of that nature. But this traffic, you can actually take SMTP traffic that you captured over the network and piece together an entire email. So there might be some useful pieces for an investigation there. Secure shell. So this one is encrypted. You will be able to see the connection attempts, but you won't be able to see any traffic that you're capturing that's SSH, because that protocol is encrypted between those two ends. Voice over IP. So this one's interesting. Like, you won't see anything human readable when you're looking at that network traffic, but you can actually piece together a media file. So if you have voice over IP phones on your network, and you have some traffic capture going on, you can actually capture entire phone calls that are traversing a network. Here's some tools. So we've already used Wireshark. It's probably the easiest to use network traffic analysis tool. You just push a button, starts capturing sucking in network traffic, and it has a lot of useful tools to filter what kind of traffic. You can right click, and there's a lot of context that you can do for analysis, and it'll put together the stream of traffic for you. It's probably one of the most widely used tools that if you're doing network traffic analysis. TCP dump. So this one's command line. So there'll be a few screenshots of this. I would say that the reasons why you might want to use TCP dump is you can actually set it to only capture traffic that you want. So for example, if you go to Wireshark and you click that capture button, it's sucking in all the traffic. That packet capture file is going to use up a lot of resources. It's going to use a lot of memory, a lot of disk space. For TCP dump, you can turn it on and say, I only want to capture web traffic. Like I was saying, there's a lot of protocols on the internet, not going to be useful from an analysis perspective. So you can actually turn on TCP dump, and it's only going to capture web traffic. So that might be more useful from an analysis perspective. Again, if storage is unlimited and cost is nothing, you capture everything. But there might be a lot of use cases where you're trying to, narrow down. You only have so much storage, you only have so much memory, so you might want to only capture your HTTP traffic for future analysis. So you can run TCP dump to just capture that kind of traffic. I would say we didn't really cover this, but I want to say Wireshark by default comes with a program called T-Shark. It's meant to be Wireshark's version of TCP dump. We're not going to do any of the labs with T-Shark. We're going to do Wireshark and TCP dump, but just to know, Wireshark understood its own limitations, so it does have a command line version that can do similar things as TCP dump. But TCP dump's been around for forever, and it's a pretty standard network analysis tool. Snort, this is a free intrusion detection system out there, and so is Suricata. They're different brands. They have a little bit of different signatures, but they both are free open source tools that can do IDS or intrusion detection prevention. There's a free tool out there that I've seen installed in tons of networks that are out there. It's called Security Onion. It pretty much combines all these tools into one operating system. So it's pretty useful out there. I've seen a lot of people take Security Onion, deploy it in an organization, and it's pretty awesome. So NetFlow, so a little bit different here for when you see the term NetFlow. NetFlow is referring to like aggregates of network data. For example, for network traffic analysis, we're looking at the specific network capture. We're looking at what specific traffic is actually going through the system. When we're analyzing NetFlow, we're actually aggregating it, so we can do statistical analysis. For example, you might have a NetFlow capture that says, we have this much gigabytes of HTTP, this much of FTP traffic, and DNS, and then you can kind of use that NetFlow to where you can outliers is probably going to be indicators of something weird on your network. Maybe you never ever have FTP on your network because you don't run any FTP servers, and then one day you see FTP traffic that's on traversing your network. That might be an indicator to go take a look at something. Maybe somebody stood up an FTP server that isn't authorized or something of that nature. But yeah, anytime you see NetFlow, it's talking about aggregates of network data. So SolarWinds, they have a good amount of free and commercial tools. It's mainly for network performance, but they have you can scan an entire IP range and get a bit of a discovery of what's on a network. I believe that's one of their free tools. They have a network map that will monitor. You can have all your routers and switches on there, and it'll monitor and it'll give you a alert if something goes down. I've never used Nagios, but it's similar. It's a network monitoring tool that you can configure to let you know if any of your network devices go down. Elastic Stack, which is Elasticsearch, Logstash, and Kibana. It typically goes by Elk. Everyone just says Elk for most of the time. It's a free logging tool. So, the Splunk is this pretty awesome, easy to use tool, but it's really expensive. And but all these tools like Elastic can ingest logs from all your systems, and you can have that one pane of glass dashboard for all of your network traffic analysis or system logs. It'll take in just about any logging, and it's a pretty standardized. There's a lot of just about everything is going to have a going to be able to be ingested by Elastic, and people have the query language is shared across a lot of security analysts, so it's easy to find a lot of support for Elastic Stack. You can read through this, but basically, um, network traffic analysis. There's a lot of different techniques, a lot of different tools. I I see it as you know, it depends on the situation for how you want to do network traffic analysis. Um, you know, from a monitoring perspective, every day you want to have it looking at useful traffic and alerting on specific things. Maybe it's alerting on spikes. Maybe it's alerting on outliers. Maybe it's alerting on specific attack signatures. Um, that's one technique and methodology for network traffic analysis, just looking at it a whole and trying to find bad things. And then there's other scenarios, right, where you have a malware alert on a host. Now you're kind of looking at a more narrow scope of network traffic, and you want to look for where's the evidence of the malware getting to this workstation. So you're kind of taking a much more narrow scope to do that type of analysis. So and then of course there's network traffic analysis from a admin engineer perspective. They're looking at uh, trying to find problems, performance issues on a network. So a lot of different methodologies, techniques that you want to take into account as to how to do your network traffic analysis. Again, I think it depends on what's the situation, what tools do I have available. Am I using free tools or paid tools? But yeah, there's a lot of mentions of free and non-free tools out there that you can use for network traffic analysis. All right, we'll take a 10-minute break, and then we're gonna go into some specific attack signatures that one section will talk about what are we looking at in Wireshark and why might it be an attack, and then we'll do the same thing with TCP dump, and then we'll kind of talk about the labs that are coming up. So take about 10-minute break. We'll start back up at 6:05 p.m. Pacific time. There you go. I was trying to talk with my mute button on. Audio screen share still good on you guys in?
Yeah.
All right. All right. We'll get back started. I would say for this, this whole portion, we're actually doing the network analysis. Yeah, don't hesitate to ask any questions. I think, like I said, this is the part where it's really kind of getting into, what we're trying to do in this course, actual investigative or real cybersecurity work. Yeah, as we're going through this, don't hesitate to ask any questions here. So yeah, we'll get started. Here's a little network analysis scenario using Wireshark. So I'm sure you guys remember this screen capture here. This is just getting started with Wireshark. You open it up and you have options for which interfaces that you want to set it to monitor. In this example here, it's set to monitor Ethernet 0. So you're typically on your one workstation, your one network interface card. Um, yeah, and then, important to note, you can actually, a lot of times if you're doing this on your laptop, you're going to have your Wi-Fi and your Ethernet, or you can set it to just monitor all of them. So, if you're on a laptop, you'll typically see like Wi-Fi 1 or Wi-Fi 0, or maybe it'll be ETH 1, ETH 0. So, might take a second to identify what it is depending on what hardware you have. But yeah, so it just depends. Be sure to check the right one when you're doing this on your own. Start the capture. So important thing to call out for Wireshark, the file. So right here in this example, we started capturing network traffic. After we're done capturing it, if we were to hit close on Wireshark, it's going to ask us, do we want to save the capture we just created? And the file format is, it's verbally, or it's called PCAP, so packet capture file. And it's standardized across just about all these network traffic solutions. You can take this PCAP in Wireshark, and you can actually open it up in TCP dump. I think there's some other online tools that are out there that can do some, and you can actually just drop in the packet capture and do some analysis through a web-based one. So this is a pretty standardized file that's used across uh, a lot of different programs. And then right here there's a PCAP NG, which is a slightly upgraded version. It's got more features than the original PCAP file. So important thing to call out though. So you can save PCAP NG in new Wireshark, and then it'll open up just fine in Wireshark. But if you were to do a PCAP NG, there's a possibility that it won't work across every single application or platform. So PCAP NG works no problem if you're using the latest versions of Wireshark, but it might not be completely compatible across older tools. So just something to keep in mind. I haven't actually run into any recent tools that couldn't open PCAP NG, but just something to always keep in mind. So in this example, there's possibly an attack going on in here. Some important things to look at, like here on the right side, you can see there's multiple SYN packets being sent. So if you guys remember, we talked about a TCP doing what's called a three-way handshake. It sends out a SYN to the remote server. The remote server sends back a SYN ACK saying, yeah, I'm here. Are you there? And it's waiting for another SYN to complete that connection establishment before it starts initiating communications between two hosts. So what you see in this example right here is a lot of SYN packets being sent out. And this here could be an example of a SYN flood attack. So a lot of times a host, it's going to create connections waiting to be established. So you send a SYN to, if it's a web server, the clients will send a SYN to the web server. Web server opens up a connection and says, I'm here. Are you there? And the attack in this version of attack, the attackers keep sending thin connections, but never establishing a connection. Eventually, the web server runs out of networking resources, and it has a bunch of halfway open connections on the receiving end. So in this example, we just see a lot of SYN packets. This would be representative of a SYN flood, a denial of service attack. So, here's this one example here, and it would say right here, it's kind of explains it out. It's an example of a DDoS SYN flood attack. And yeah, so here's one example. And a lot of times, if you're, from a network monitoring and prevention scenario, this is something where you would have maybe your intrusion prevention system will block the IPs if it's sending too much SYN packets without closing that or completing that SYN-ACK through a handshake. So yeah, there's one example right here of a network traffic view of an actual attack. Any questions? It's really simplified for this example, but any kind of questions on what we're looking at here. So, and I'll kind of over each column. So in the left side, Wireshark captures the sequence or the amount of packets right here. So 1 through whatever, and this is specific to when you start your capture to when you end the capture. So if Wireshark captured 100 packets, this would scroll all the way down and get to 100. Timestamp format here, it goes all the way down to this fraction of a second. I'm not quite sure what the word is for this microsecond or similar. Source IP, the originator traffic, destination IP, the recipient of the traffic, the protocol. If there was other traffic here, you'd see ICMP or UDP, and then the packet length. So let's say this is in bytes, so this is 54 bytes. And then the info section is where Wireshark is doing some interpretation of the packet. It's saying for this first row, the source port is 2555. The destination port is 22746. And it's interpreting that this is a TCP SYN sequence 0, and I'm not sure what win is, and length would be length of packet. So this is we went over the let's see. So let's do TCP packet header. So it's interpreting this and displaying it in human readable format. This top left right here, source port 16 bits. It's is that if you were actually look at the binary, it would translate. It would go from binary to whatever zeros and ones it is to translating to 2555. And then we have a sequence number. So all of this is actually Wireshark is taking this, so you don't have to do it as the human doesn't have to go in and translate the binary or hexadecimal. It's just Wireshark is just doing that intelligence for us and translating all this information right here. Questions on this one? I'll move on to the TCP dump example. So again, this is a command line tool. There's a lot of different advantages that you can use for TCP dump. I think I think the biggest thing I said was you can actually upfront tell it you only want to capture certain types of traffic, and that's really useful because in this example, Wireshark copied everything, and then captured everything, and now we're just filtering out the traffic we want. So you can do that up front to save on your memory and disk space. So TCP dump, I want to say it's installed on your guys' lab machines. I want to say it's on the Kali Linux machine, but you can actually install it on any Linux distro. You can just do like how we did those install commands. You can do sudo apt install TCP dump, and you can actually get it running on just about any Linux system. Important thing, just like in Wireshark, it needs to have administrator privileges. It needs to have full control of the network interface. So, the example command here, sudo TCP dump -I is for interface, and Ethernet 0. That would be to start it up to where it's just monitoring everything on ETH 0. And here's the example. So it's actually going to just display it live on screen. So it's actually, when it's running, it's really difficult to look at because it's going to keep scrolling through your screen until you tell it to stop. So this isn't actually the best way to run it, but at least you see some output knowing that the command is running. So in this example, instead of running it with just sudo TCP dump I ETH 0, we're actually going to run the same command, except we're going to add a -W for write and a file name.pcap. So in this version, it's just displaying to screen and it's not saving a file, which typically isn't that useful. We want to run TCP dump and actually save the output so we can do some further analysis. So this example is a much better way to run it. So we're saving it to a PCAP. Now you can take, like I was saying before, you can actually open up PCAPs in TCP dump. So in this example, TCP dump -R file name.pcap. So this is where you can actually even take one from Wireshark and open it up in TCP dump. And then, in this example right here, we can add a filter at the end, at the bottom, where we're capturing only port 80. So it's only going to capture HTTP traffic. So if we wanted to do, TCP dump -I Ethernet 0 -W, we're going to write to file name.pcap and then port 80. It would save a file and it would be only port 80 traffic. It would, it would ignore all the DHCP, all the ARP, all these protocols that may not be important for what you're trying to do analysis on, and you get a significantly smaller file size, using way less memory and resources for your analysis. So this example right here is actually not malicious right here. So what we're typically seeing is DNS traffic. The output isn't as human readable as Wireshark is. So I'll kind of go over the very first row here. So far on left, we have a timestamp. Again, it's going down to six numbers after the decimal symbol for seconds. So like a microsecond or something. And then the left one is the originating IP. So 10.0.2.15. And there's a dot and 5 numbers. This is actually the source port. So traffic's coming out of 10.0.2.15 on port 507.0.3. And then we have that little arrow pointing to the destination, and the destination 192.168.1.1. And this is where it does something a little bit different. So it says 192.168.1.1, and then it says .domain. It's actually telling you that it's domain name services. So instead of putting a .53 for destination port, it's saying domain as domain name service traffic. So that's where it's trying to tell you what it thinks the protocol is. So TCP dump saying domain. And then we have the length right here. So not typically important, but it's 56407. And then on the far right, it's actually interpreting some of the information. So it's actually a DNS request for contile.services.mozilla.com. And so as you can see, it's domain name traffic reaching out to find out the IP for these Mozilla.com addresses, and then you can see it actually returning some IPs. So like, let's see, what row is this? 1, 2, 3, 4, or about the fourth row down. You can actually see the domain server where 192.168.1.1 becomes a source host, and it's sending back this 34.117.188.166. So this one right here is actually not malicious traffic. It's just your average day-to-day DNS traffic. But as an example, it's breaking down TCP dump, showing this DNS traffic right here. And then you can see a bit more lower down where you can see maybe the last row. It's actually doing HTTPS traffic. So it's sending a web page back to a user. So again, it's not as user friendly as Wireshark, but you can actually chop up a lot of these things in command line. So if you know what you're looking for, it can operate way more quicker, way more optimized. And yeah, so basically this slide kind of breaks out what the story we just said with the host requesting getting a DNS record for this Mozilla server, and yeah. All right, that's it for the intro to Wireshark and TCP dump. I'm gonna go over the lab for today. So we're gonna do some practice with TCP dump and Wireshark. You would have to go into your Windows machine, open up Hyper-V, and actually start up some clients. So we're going to start up our Kali box right here. And then from there, you can log into Kali from within Hyper-V. And keep note, here's the password for default. Kali is user Kali, password Kali. And then in this example, we're gonna, just like I was saying, I want to say it's going to be like this where it's already installed TCP dump. I want to say typically Kali Linux does run with it, but we'll go through that command, and you'll do some playing around with it, do some packet capture, and also open up Firefox to generate some traffic. And then we'll run it with where you make sure you're writing it to a capture file. And see, so, and it's in this example, you're going to open it up with a text editor, and because it's not in ASCII text, this is what it'll look like if you try to open it up in a text editor. So yeah, definitely not friendly to view binary like that. So and this is where you're going to take that packet capture and actually open it up in Wireshark. So you're going to create a packet capture with TCP dump, open it up in Wireshark, and you should see some things similar. It's not going to be exactly the same because you're generating the traffic, but opening up the browser and doing a little bit of just that little bit, it should generate some DNS traffic, some HTTP, and then in this, we're going to actually show where you're creating some traffic that could be similar to a ping flood. So it'll have you run ping, keep it running. It'll keep running for as long as till you hit Control C to end it on Linux, or even if it's -T on Windows. So yeah, you'll be generating some traffic and then doing some filters in Wireshark to observe how that looks. I'll leave the rest for you all to work on. I don't want to give the whole thing away, and then of course we're gonna do some SSH, so you'll get to see um, how you can only view some fields that's in SSH because it's encrypted, but not everything because that's the nature of SSH. It's going to be encrypted. Um, but yeah, so this will be the lab for today and tomorrow, and then on Thursday we'll cover network attacks and defenses. Questions, concerns? I'll be on for about 25 more minutes if you guys are getting started on the lab today. If not, Joel will be available tomorrow as well for this practice lab.
Yeah, I am available.
But that's all for today. Thanks, everyone.